Alright, I'd like you to open your journal to page 17. We're going to be on the right side again. We're going to add a couple more examples today. If you remember, yesterday we talked about solving one-step inequalities, and we focused in on how to solve by addition or subtraction. Before we get on to today's examples, I would like to go over the two rules again that you need to remember when you're solving inequalities. First one, the one we talked about most yesterday, is that the variable always goes on the left side of the inequality. So if you are working a problem and you've got a variable or a letter on the right side, once you get to your final answer, you do need to rewrite it so that the variable will be on the left side. And you can't just move the variable, you have to go ahead and change the direction of the symbol as well. Make your less than sign a greater than sign, and vice versa. Today we're going to be looking at the next rule, which says when you are multiplying or dividing both sides of an inequality by a negative number, the inequality symbol will change directions. And we're going to talk about why that is and how that works in today's examples. Alright, let's go ahead and move down onto the page, and we're going to write some examples on how to solve with multiplication and division. We are still looking at one-step inequalities, but instead of addition and subtraction, today we are looking at how to solve when we either multiply or divide to get that variable by itself. So for our first example, I'd like to do 3x greater than 6. To solve for x on this one, we are still doing those opposite operations, which means in this case we're going to be dividing both sides by 3. Well, on the left side, our 3's will cancel out, which is going to leave us with just an x greater than 2, because 6 divided by 3 is 2. So now we can graph it. I've got my 0 in the middle, and I've got from 0 to 2 on the right side. I'm going to use a open circle and shade to the right. Open circle because there's no line under our greater than sign, and shaded to the right because that is the direction that the greater than sign is pointing. Next, let's do 2 less than or equal to x over 3. So that means that x is now being divided by 3. The opposite operation of division is multiplication, so to solve for this one, we are going to multiply both sides by 3. 3 times 2 is 6, so we've got 6 less than or equal to x, since our two 3's on the right side have canceled out. Well, we've got an x on the right side, and we learned yesterday that that means that we have to take the whole inequality and flip it. So we're going to end up with x greater than or equal to 6. We can graph that on a number line. I'm going to count all the way to 6 by ones. I'm going to use a closed circle and shade to the right. Alright, our next example is 4 less than or equal to a negative 2x. On this one, we're going to divide by a negative 2. 4 divided by negative 2 is negative 2. The 2's on the right side have canceled out. And now we need to remember that second rule of inequalities is that you have to flip your inequality symbol when you multiply or divide by a negative 2. So instead of being less than or equal to, we're going to have greater than or equal to, and finally our x. Now we still have the x on the right side, so we're going to need to change our inequality, where we've got the x now on the left, x less than or equal to a negative 2. So now to graph that one, I'm going to use a closed circle on negative 2 and then shade to the left. Alright, I also wanted to kind of explain why we change the direction of the inequality symbol. And remember, the goal of solving is to get a number or an expression that you can plug in for the variable and end up with a true statement. So let's try this with just some numbers and see how changing the numbers by multiplication or division changes the statement that we have going on. So let's start with 1 less than 2. That is a true statement. So let's say we are going to multiply both sides of that by a -2. Well, 1 times a -2 is -2, and 2 times a -2 is a -4. Well, that right there is a false statement because -2 is not less than -4. In order to make it true again, we have to change the direction of our inequality symbol, giving us -2 greater than -4, which is true.